Hello everyone, good afternoon. Good afternoon to all. I welcome you again on the official channel of the Gate Academy. So, we are moving with our series of most expected concepts with super questions. We have discussed some most important concepts of geotechnical engineering in our last 4 sessions. This is our 5th session on geotechnical engineering. Today, we are going to discuss some quality questions and concepts from our foundation engineering. Foundation part we are going to cover. So in last class we have discussed about slope stability. We have discussed about earth pressure theories. So now let's start today's session. Okay. So this is our first question from foundation engineering. First question from Terzaghis theory. First question is from Terzaghi theory. The question reads, a strip footing of width 3 meter is founded at a depth of 2 meter below the ground surface having a cohesion value. C value is given to you and the angle of shearing resistance phi value is 38 degree. It means it is a C5 soil. The water table is at a depth of 5 meter below the ground level. The unit weight of soil above the water table is 17.25 kilonewton per meter cube. Determine the net safe bearing pressure for a factor of safety equal to 3. So, bearing capacity constants are given. NC, NQ and N gamma values are given to you. For phi is equal to 38 degree. For phi is equal to 38 degree, NC, NQ, N gamma are given to you. And you need to find the net safe bearing pressure. Or you can say the net safe bearing capacity you need to find. You need to find the net safe bearing capacity of this foundation. Find the net safe bearing capacity of the soil in which the foundation, whose width is 3 meter, depth is 2 meter, and properties of soil are given to you. And properties of soil are given to you. Yes, good afternoon. Good afternoon, everyone. Good afternoon to all. Now try this. We know that Terzaghi has given its relationship for strip footing. For strip footing, Terzaghi has given the relationships to find the ultimate bearing capacity. We need the net safe bearing capacity of the soil. We need to find the net safe bearing capacity. Try to answer. Try to answer. Okay. Okay, let me discuss. Let me discuss. Suppose this is our footing. This is the footing having width equal to B. It's having width equal to B. And depth of footing. Depth will be measured from the ground level. Suppose this is the ground level. So depth of footing it is, suppose DF. Suppose DF. Now, the properties of soil in which this foundation is there, those properties are given to you. That is C and phi values are given to you. What is the net bearing capacity of soil? how much pressure this soil can bear safely. That is our ultimate bearing capacity. Now, if I am saying net bearing capacity, it means the pressure exerted by the superstructure on this soil. If we are considering only that pressure, that is our net pressure. That will be our net pressure, right? Suppose if I say ultimate bearing capacity, what will be the ultimate bearing capacity? The maximum pressure which can be supported by this soil without shear failure. Now that pressure will include, suppose this is any load coming from the superstructure P. So the pressure due to this superstructure load, pressure due to superstructure load, or the load which is coming on this column, you can say, plus there will be a pressure due to this soil. The soil will also exert some pressure here. That will be equal to, this pressure will be equal to gamma into dF. If gamma is the unit weight of soil, this depth of foundation, this weight of soil will also exert some pressure on this foundation, plus pressure exerted by soil above foundation level. This is our ultimate bearing capacity. If I am saying net bearing capacity, it will be due to, if I am considering only the pressure exerted by superstructure, this part, that is my net bearing capacity. So the maximum pressure which soil can bear due to the load exerted on the column, or the load which is transferred by the column to the foundation, that is our net bearing capacity. So pressure due to superstructure load, right? Now ultimate bearing capacity we represent by QU, and net bearing capacity we represent by QNU. Now Terzaghi has given the formula for ultimate bearing capacity, that is QU is equal to, if it is a strip footing, it will be CNC plus NQ into gamma into DF plus half gamma into B into N gamma. Now this is the ultimate bearing capacity. We need net bearing capacity, so QNU, it will be equal to QU minus the pressure exerted by the soil above foundation level, that is gamma into DF. Now in question it is asked to calculate net safe bearing capacity. So QNU safe. Now to calculate the safe bearing capacity, if I divide this net bearing capacity with factor of safety, I am going to get the safe bearing capacity of the foundation, or the soil which is supporting that foundation, right? So this is the value we need to calculate. This is the value we need to calculate. Now, let me discuss more. Here we have three terms. 1, 2, and 3. And 3. Now we know that the influence level or the influence region of this foundation means up to which this foundation is going to distribute its stresses. It is up to the width of foundation B. It is up to the width of foundation B, right? So if I am writing this gamma into B, this gamma into B, this term is for the region. Suppose I have given it 3, I am taking it third zone. I am taking it as third zone. This term gamma into df, it means gamma into df, pressure which is exerted by this part, So our second term is governed by this portion of the soil. Part 2. This is our part 2, right? So the soil below width B has no effect. The soil below width B has no effect on the bearing capacity of soil which is exerted on this foundation, or which is supporting this foundation load, right? Now let's get back to our question. Data given us to is that the data given is width of foundation is given. It means B value is given to us. B value is given as 3 meters. Depth of foundation is given. It means DF value is given as 2 meters. Cohesion value is given. P 30 kilonewton per meter square. Phi value is given. Phi is only needed to calculate NC, NQ and N gamma. Here NC, NQ, N gamma are given to us. Now it is given that water table. Let me draw this situation. This is our foundation. Having width equal to 3 meters. Its width is equal to 3 meters. What is, suppose this is the ground level. If this is ground level, depth of foundation is 2 meters. 2 meters. Now the zone of influence up to which this footing is going to transfer its load, it is up to B distance below the foundation level. B distance below the foundation level, it means up to this level. This is also 3 meters. Now it is given that the water table is at a depth of 5 meters below the ground level. This is our ground level. Water table is at 5 meters. It means there will be no influence of water table on the bearing capacity of this soil. There will be no effect of water table on the bearing capacity of our soil, as it is away from the zone of influence. Right? So I can calculate ultimate bearing capacity QU, that is CNC plus NQ into gamma into DF plus half gamma into B into N gamma, Let's put the values. C value is given it is 30 kilonewton per meter square. NC value is 57.8. NQ value 41.4. Gamma, unit weight of soil. If unit weight of soil is given, yes, unit weight of soil is given as 17.25, as 17.25 into DF. DF is 2 meters, depth of foundation, plus half. Gamma value is same, 17.25 into B. Width of foundation is 3 into N gamma, 42.4. Calculate this value. Calculate this value. Calculate QU value. What is the value of QU you are getting? Calculate the value of QU. Ultimate bearing capacity. Calculate the ultimate bearing capacity. Calculate the ultimate bearing capacity. Okay, so our ultimate bearing capacity, it is coming to be 4259.4 kilonewton per meter square. You can also check from your side if calculations are correct. 4259.4. What we need? We need net safe bearing pressure. So let's calculate net bearing pressure QNU. It will be equal to QU into gamma minus gamma DF, the pressure which is exerted by this soil, the pressure which is applied by this soil above foundation level. So QU is our 4259.4 minus gamma DF. Gamma is 17.25. Depth of foundation is 2. Depth of foundation is 2. So this is my net ultimate. Now I need the net safe bearing pressure, QNS. Net safe, it will be equal to net ultimate divided by factor of safety. Net ultimate divided by factor of safety. If factor of safety value is given to us, yes, factor of safety is given as 3. Factor of safety is given as 3. So it will be 4259.4 minus 17.25 into 2 divided by 3. Divided by 3. Let me know in the comment box what is the value you are getting for net safe bearing pressure. What is the value of net safe bearing pressure you are getting? What is the value of net safe bearing pressure you are getting? So the net safe bearing pressure we are getting as 1408.3 kilonewton per meter square. Kilonewton per meter square. So the correct answer will be our option C. Our option C will be correct. So 1408 kilonewton per meter square. This is our net safe bearing pressure. Okay, just move to next question. Okay, now this is the question from your plate load test. Now the question is from plate load test. Try this one. Try this one. A 300 mm square bearing plate settles by 21 mm in a plate load test on a cohesive soil when the intensity of loading is 0.2 Newton per mm square. The settlement of a prototype shallow footing, which is 1 meter square. It means it is of size 1 mm, 1 meter into 1 meter, under the same intensity of loading is. Under the same intensity of loading. It means first you have conducted a plate load test. You have conducted a test on a plate of size 300 mm. at a stress of or at a loading intensity of 0.2 Newton per mm square, you got the settlement value as 21 mm. You got the value of settlement as 21 mm. Now based on this result, we need to find the settlement of footing whose size is 1 mm into 1 mm. Whose size is 1 meter into 1 meter. A square footing of 1 meter size. Now what will be the settlement value for this shallow footing? You have to answer what will be the value of settlement for this square footing. Try this one. Try this one. You can just note the data. By then, just let me discuss about this plate load test. Our plate load test. Plate load test. I will give you a brief description what is our plate load test. So we know that this is a field test. Field test mainly designed for calculation of your subgrade reaction, modulus of subgrade reaction. We calculate for the calculation of or for the design of our rigid pavement or flexible pavement. Which type of pavement we design using modulus of subgrade reaction value. Our modulus of subgrade reaction value. So it is needed in your rigid pavement. So for that we have designed this plate load test, but we can also use this for calculation of our bearing capacity of foundation and bearing capacity and settlement of the foundation. So what we do in the field at the foundation level, we put one plate, one metal plate having size from 30 to having size of from 30 centimeter to 75 centimeter or 90 centimeter is also available, right? So what we will do, we will place our plate at the bottom of this excavation. Now this depth is equal to the depth of actual foundation. This depth should be equal to depth of actual foundation. This is equal to df. This is equal to df. And width of this excavation should be, it should not be less than 5 times the width of this plate. If this is the width of plate, to eliminate the effect of end contractions, to eliminate the effect of these boundary conditions, this excavation width, it should not be less than 5 times of width of plate. Now what we do, using the jacking mechanism, what we will do, we are going to apply load over this plate. And using dial gauges, we are going to measure what will be the settlement of this footing with the application of load, right? So what we do in starting, we just apply one sitting load. We just apply a sitting load so that this plate get correctly settled over the surface. So one sitting load is applied of 7 kilonewton per meter square, having intensity of 7 kilonewton per meter square. After that, these dial gauges readings are set at 0, and after that the actual test starts. So what we will do, we will apply the load over this plate, and for that load we are going to calculate what is the settlement we are getting. So for different loading we will get settlement value. So here it is load, here it is settlement. Here it is settlement. So suppose at any particular load the soil fails, how it will appear? There will be a sudden settlement. There will be a sudden settlement. Generally this type of variation we got in stiff soil. If soil is stiff, we will get a exact failure point. If suppose it is a loose soil, you will generally get a progressive curve. Right? Now, the load at which this soil fails, it will be our maximum load which soil can carry. It is the maximum load which soil can carry before failure. If I divide this load by area, this will be my ultimate bearing capacity, or QU. This QU will be for this plate. So this is QU of plate. Right? Now, for this loose soil, how we are going to calculate this QUB? As there is no exact failure point we are getting, so we can use either tangent method. We draw one initial tangent and one final tangent, and the point where these two tangents intersect each other, corresponding to that we get QU of plate. Or we either can represent this load, or you can say pressure versus settlement curve, in log scale. Then also we will get one exact failure point, one exact failure load at which our soil fails. Right? Now we get QUP, that ultimate bearing capacity of plate. We will also find settlement of plate. So these two values we are going to get from this test. Now there are some correlations which can relate the ultimate bearing capacity of plate with the value of ultimate bearing capacity of foundation. Similarly, we have correlation of between the settlement of plate and settlement of foundation. Now based on the type of soil, so suppose if it is a cohesionless soil, or you can say soil type is sand. If soil type is, let's first take clay. If soil type is clay, so the ultimate bearing capacity of foundation, it will be same as the ultimate bearing capacity of plate. It means the size of foundation has no effect on the bearing capacity of soil if the soil type is clay. So QU of foundation, it will be same as QU of plate. So we have calculated QU of plate, ultimate bearing capacity of plate, it will be same as the ultimate bearing capacity of foundation if soil is clay soil. Now if soil type is sand, cohesionless soil, in this case ultimate bearing capacity, it is directly proportional to the size of plate. So QU of foundation by QU of plate, it will be equal to width of foundation by width of plate. Right? Now this is about the bearing capacity. If we need to calculate the settlement, this is for bearing capacity. If you want to find settlement, if we need settlement value, then if soil type is clay, first case soil type is clay, Soil type is clay. So the settlement of foundation by settlement of plate, it will be correlated as width of foundation by width of plate. Width of foundation by width of plate. Second, if soil type is sand, the settlement of foundation and settlement of plate, they are correlated as width of foundation by width of plate, width of foundation by width of plate, width of plate plus 0.3, width of foundation plus 0.3, width of foundation plus 0.3, and this value whole square, and this value whole square. So these are our 4 correlations based on which we can calculate the bearing capacity of foundation and settlement of foundation, if soil is clay soil or sandy soil, right? So now just back to our question. 300 mm. What is this 300 mm? This is our width of plate. So width of plate is given as 300 mm. Square bearing plate settles by 21 mm. It means the settlement of plate is given to us as 21 mm. Settlement of plate is given to us 21 mm. Intensity of loading is same, so that will have no effect. The settlement of prototype, it means we need settlement of foundation. If the width of foundation is given as 1 meter, width of foundation is given as 1 meter, just convert it to meter also, 0.3 meters. 0.3 meters. Now type of soil is cohesive soil. It is given here, it is a cohesive soil. It means sea soil. So what will be the relation? Settlement of foundation by settlement of plate, it will be equal to width of foundation by width of plate, width of foundation by width of plate. So if I calculate the settlement of foundation, it will be width of foundation, that is 1 upon width of plate, 0.3, multiply by settlement of plate. We need answer in mm, so we can put settlement of plate in mm only. 21. So we will get 70 mm. We will get 70 mm settlement of foundation. So the foundation settlement will be 70 mm. Right? I hope now the concept of this plate load test is clear. How to tackle the question from this point and how the questions are going to be there from your plate load test. There are 4 parameters. 3 will be given to you and 1 you have to calculate. 3 will be given to you and 1 value you have to calculate. Right? Okay. Let's move to our next question. Now this is a database question. Permissible settlement is relatively higher for. Although this is a database question, but on your civil engineering judgment also, based on your civil engineering judgment, you can answer this. Even though you don't know the values, then also you can answer this one. Permissible settlement is relatively higher for. permissible settlement is relatively higher for first is isolated footing on clay, isolated footing on sand, raft on clay and raft on sand. Raft on clay and raft on sand. Try to answer this one. Try to answer for which type of foundation and on which soil you are going to get higher permissible settlement. Yes, Jay. Jay has given answer as C. Yes. Yes. Raft on clay. It will have maximum permissible settlement value. Can you give me the value? What is the permissible settlement for raft on clay? Can you give me the value? Can you give me the value? What is the permissible settlement? What is the permissible settlement value for raft on clay? Okay, let's just give me the values for this. Now these values are as per IS 1904 1966. If we talk about isolated footing on clay, isolated footing on clay, so the permissible settlement value suggested by code is 65 mm. It is 65 mm. Similarly, if it is isolated footing on sand, the permissible settlement value is 40 mm. Permissible settlement is 40 mm. Okay, if voice is not clear, is it so? Voice is not clear? Let me know if voice is not clear. Is there any other student who is facing this problem with voice? Any other student also facing problem with voice? Okay. Clear? Okay, Shahid. Okay, it's full from my side. The voice is full from my side. Just check once, Harsa. Now, the raft on clays. If I talk about raft on clays, the permissible settlement, it is 65 to 100 mm. It is 65 to 100 mm. Whereas on raft on sand, it is 40 to 65 mm. 40 to 65 mm. Now, even though, suppose I don't remember these values, if I don't remember these values, how to answer this type of questions? Which soil will have more settlement, more permissible settlement? Which settles more or which settles less? For which soil you will provide? If suppose you are the authority who is going to make this IS code. You are the authority who is going to make this IS code. So for which type of soil your permissible settlement will be more? The soil which settles less or the soil which settles more? The soil which settles less or the soil which settles more? For which one your permissible settlement value will be more? Let me know in the comment box. आप कौन सी सॉइल के लिए ज्यादा परमिसिबल सेटलमेंट रखोगे? द सॉइल जिसमें सेटलमेंट कम होता है या फिर ऐसी सॉइल जिसमें सेटलमेंट आपका ज्यादा होगा? जिस सॉइल में आपके पास सेटलमेंट ज्यादा होने वाला है उसमें परमिसिबल सेटलमेंट की वैल्यू ज्यादा होगी, या फिर ऐसा सॉइल जिसमें सेटलमेंट कम होता है उसमें परमिसिबल सेटलमेंट की वैल्यू ज्यादा होगी? इन विच टाइप ऑफ सॉइल द परमिसिबल सेटलमेंट विल बी मोर? Obviously I'm going to take the permissible settlement value more for that soil which is going to settle more. जिसमें भी आपका सेटलमेंट ज़्यादा होता है उसमें आपको परमिसिबल सेटलमेंट की वैल्यू भी बढ़ानी पड़ेगी, राइट? So out of clay and sand, in which soil there will be more settlement? If I am talking about settlement, it means final settlement. In clay and sand, in which soil you are going to get more settlement? Out of clay and sand, in which soil you are going to get more settlement? In which soil you are going to get more settlement? Obviously in clay. So clay soil, in clay settlement will be, or you can say settlement. Yes, Jay. Can you give me the reason why the settlement of clay is more than settlement of sand? Can you give me the reason why settlement of sand is more, settlement of clay, it is more than settlement of sand? So settlement in clay, it will be greater than settlement of sand. Settlement of sand. What will be the reason? What will be the reason? As there is void ratio is, as void ratio of clay is greater than void ratio of sand. Void ratio of clay is more than void ratio of sand. Ultimately, the settlement is due to the decrement of, no, not about water content, as the settlement is due to the decrease of this void ratio. So whichever soil is having more void ratio, whichever soil will be having more void ratio, for that settlement value will be more. So the void ratio of clay, it is more than void ratio of sand. If I say for which type of soil, clay or sand, the rate of settlement will be more. The rate of settlement, if I say rate of settlement of clay, and I am saying rate of settlement of sand, which value will be more? For which type of soil rate of settlement will be more? Just give me the answer. For which soil the rate of settlement will be more? So the rate of settlement will be more for sand. The rate of settlement, it means किसमें जल्दी सेटलमेंट आपको देखने को मिलेगा? In which soil after application of load, which soil will get settled in less time? For that soil the settlement, or you can say the rate of settlement will be less. So the rate of settlement of sand, it will be greater than rate of settlement of clay. What is the reason? What is the reason? As the permeability of clay, it is less than permeability of sand. Ultimately the settlement is going to be the decrease in void ratio. Now void ratio कब decrease होगा? जब आपका water expel out होगा from the voids. When this water in your voids, it is going to expel out, then only there will be decrease in void ratio. Now water can expel out, or water can, the ease with which water can drain out from your soil, it will depend upon the property of permeability of soil, right? The permeability of sand, it is more than the permeability of clay. That's why the rate of settlement for sand will be more than the rate of settlement in clay. For this you can also refer this figure. Suppose here it is time, this is your time, this is your settlement. if I am saying clay, so clay, for the settlement of clay, its magnitude will be more, but the time taken is also very high. So this is the ultimate settlement value for this clay, and time taken is this one. Whereas if I talk about sand, this is for clay. Now if I talk about sand, what will be the case? The ultimate settlement value will be less, but the time taken for this ultimate settlement is also less. It means the rate of loading, which part of this graph is going to tell me the value or the rate of settlement? Which part of this graph is going to give me the value of rate of settlement? The rate of settlement value, which part of this graph is going to get? That will be our the slope of this graph. The slope of this graph. So slope of this graph is this one. For sand, the slope of the graph is this, right? So this is clay, this is sand. This is sand. So the correct answer for this question will be option C. Now if I have to compare between raft and isolated footing, for which type of footing the permissible settlement will be more? Obviously for that type of footing for which the soil can support more load, or you can say the soil fails at greater settlement value. If suppose I take the case of isolated footing, this is my isolated footing. This is isolated footing. It means this part is going to transfer its load to soil. Suppose it settles by X amount. Now second case is a raft. Second case is our raft. Right? This is our raft foundation. So from this we can judge that the permissible settlement will be more for this case as compared to this isolated footing. So even though if I don't remember these values, I can judge that for raft on clay will have more settlement value other than these cases. Clear? Okay. Now just move to our next question. If you are having any doubt, you can ask. अगर आपका कोई भी डाउट है आप पूछ सकते हैं. If you are feeling any doubt, any confusion, you can ask. Okay. Again, the question is from your Tarzagi's theory. Again, the question is from Tarzagi theory. Now, can you tell me for which type of shear failure Tarzagi relations are valid? The relation given by Terzaghi as Q ultimate is equal to CNC plus NQ into gamma into DF plus half gamma B into N gamma. While given this relation, what is the type of shear failure? What is the type of shear failure Terzaghi has assumed? Which shear failure Terzaghi has assumed? So Terzaghi's assumption was the failure of soil, it is general shear failure. It is general shear failure. Right? Now let's read the question. A 4-meter wide strip footing is founded at a depth of 1.5 meter below the ground surface in a C5 soil as shown in the figure. The water table is at a depth of 5.5 meter below the ground surface. The soil properties are given to you. You need to find the values of bearing capacity factor for different 5 values are given to you. Using Terzaghi's bearing capacity equation, the value of ultimate bearing capacity is now here the important point is this phi value. Phi value is greater than 32 degree. Phi value is greater than 32 degree. Phi value. If phi value is greater than 32 degree or phi value is greater than 28 degree, for which value you are going to get your local shear failure? For which phi value you are going to get the local shear failure? At which value? At which value? At which value you are going to get the local shear failure? If phi is greater than 32. Okay. So when there is local shear failure, it means here the type of failure is local shear failure. Now Terzaghi's relations were given for general shear failure. Terzaghi's relations are for general shear failure. Whenever there is a local shear failure, whenever there will be a local shear failure, you are going to use which shear parameters? There will be modified C and phi value. Right? Now we know that NC, NQ, gamma, and gamma, they depends upon the angle of internal friction phi. So NC, NQ, gamma, you have to take corresponding to that modified phi value. Right? So what are the modified C and phi values? For local shear failure. For local shear failure. We have to use modified C value. Use modified C and phi value. Modified C value will be equal to 2/3 of cohesion value at general shear failure C. Similarly, tan phi modified, it will be equal to 2/3 times of tan phi. So it is 2/3. What is the value of C? It is 35. It is 35. If I calculate phi modified, it will be equal to 10 inverse 2 by 3, 10, 34.97. Just give me the value of modified phi value. Give me the value of modified phi value. What is the value of modified friction angle you are getting? So modified phi value, it is equal to 25 degree. We are going to get 25 degree. It means the NC, NQ, N gamma which we have to use will be these values. These values we are going to use. These values we are going to use corresponding to 25 degree. So our NC value is 25.1, NQ value is 12.7 and N gamma value is 9.7. So NC is 12.1, .1. NC is 25.1. NQ value, it is 12.7 and 9.7. 12.7 and 9.7. That is N gamma. N gamma. Now we can use the Tarzagi's relation. We can use the Tarzagi's relation. We need to find ultimate bearing capacity, QU. That is CNC. Here C will be C modified now. Plus NQ into gamma into DF. Plus half gamma B N gamma. Yes, if you get a value between 20 to 25, although these relations are not to be linear, generally the interpolations are done for the linear relations, right? But generally if you see the variation of your NC, NQ, N gamma value with phi, that used to be non-linear variation. So if examiner is making one question from this topic, he will give you the value corresponding to the phi value you will get. But in case if you are getting, suppose you got the value as 23. So now you have to interpolate for NC, for NQ, for N gamma. For NC, for NQ, N gamma. That will be a tedious process. So in exam, you are going to get the exact value. Either it can be, suppose you get 25.1, then also you have to assume it as 25. Suppose you get 24.8 or 24.9, then also assume it as 25, right? So interpolation we generally get for if the variation is linear. So now our C modified is 2 by 3 times of C, that is 35. NC value is 25.1 plus NQ 12.7, gamma value, unit weight. Now gamma saturated is also given, gamma bulk is also given. Now we have to draw the profile just to see if there is any effect of water table or not. So here it is our foundation. Here it is our foundation. So depth of foundation is given as 1.5 meter. Depth of foundation is given as 1.5 meter. This is our ground level. And width of foundation, it is 4 meter. 4 meter. The zone of influence up to which this foundation is going to transfer its load, it will be up to the width of foundation. It will be equal to the width of foundation below the foundation level, that is 4 meter. So complete depth becomes 5.5. Complete depth is 5.5. Now the water table is given at a level of 5.5 meter below ground level. It means it is below the zone of influence. Water table is below the zone of influence. So we have to use our gamma bulk value. So the value will be used as gamma bulk. We are going to use gamma bulk, right? So gamma is 17 kilonewton per meter cube. So 17 kilonewton per meter cube. Depth of foundation is 1.5. Depth of foundation is 1.5 plus half gamma unit weight 70, width is 4 meter, and gamma value is 9.7. 9.7. Give me the value of ultimate bearing capacity. Give me the value of ultimate bearing capacity. Yes, Jay, give me the value of ultimate bearing capacity. What is the ultimate bearing capacity you are getting? What is the value of ultimate bearing capacity you are getting? Just solve this one. It is multiply C and C plus NQ gamma DF plus half gamma B and gamma plus half gamma B and gamma. So it is equal to 1239.816 kilonewton per meter square. Kilonewton per meter square. So correct answer will be our option A. Our option A will be correct. I hope now the concept of local shear failure. If the shear failure is local shear failure, what will be the changes in your standard formula given by Tarzaghi that we have seen? Okay, our next question. Now let's see the effect of water table. Effect of water table. Effect of water table on the bearing capacity of soil. Now the question reads, the percentage reduction in the bearing capacity of strip footing resting on sand using flooding condition. Under flooding condition, water level is at the base of the footing when compared to the situation where the water level is at a depth much greater than the width of footing is approximately. So in first case, the water level is much below, at a greater depth below the zone of influence up to which soil is going to transfer its load. And in second case, the water level is at ground level. So what will be the reduction in bearing capacity that you need to find? What will be the reduction in bearing capacity that you need to find? Try this one. Try to answer this one. What will be the reduction in bearing capacity if water level rises from a much greater depth to the foundation level or to ground level, to the ground level? Not to the ground level, it is given up to the base of the footing. So water table rises up to the base of the footing. Base of the footing. Now, one important part is also that it is resting on sand. The footing is resting on sand. The footing is resting on sand. So suppose this is our sand. This is the sand layer, and foundation is at this level. It is not below the ground surface. It is at ground surface. Foundation is at ground surface. If foundation is at ground surface, what will be the depth of foundation? What will be the depth of foundation? If foundation is at ground level, what will be the value of depth of foundation? What will be the value of depth of foundation? Suppose width of foundation is B. Suppose width of foundation is B. Width of foundation is B. Now in first case, the water table is at greater depth. Suppose up to this level it is B only. This distance is also B. That means this is the zone of influence. Now in first case, water table is suppose at this level. In first case, water table is at this level. It is at this level. What will be the value of? What will be the value of bearing capacity of soil? What will be the value of bearing capacity of soil? Now it is given, it is a sand. It means C value will be 0. It means C value is 0. तो आपको हर एक वर्ड पे ध्यान देना होगा. सैंड दिया हुआ है तो C वैल्यू 0 है. रेस्टिंग ऑन सैंड दिया हुआ है, इट मीन डेप्थ ऑफ फाउंडेशन आपको बता रहा है कि 0 है. तो ये आपको डायरेक्टली गिवन नहीं है. दैट यू हैव टू एनालाइज फ्रॉम द क्वेश्चन. That you have to analyze from the question. Now if I calculate QU according to Terzaghi, it is CNC plus NQ gamma DF plus half gamma into B into N gamma. Now if C value is 0, this term is going to be 0. If DF value is 0, this is going to be 0. So your QU relation become half gamma B N gamma. हाफ गामा बी एन गामा. क्या वाटर लेवल के चेंज होने से गामा पे कोई इफेक्ट होगा? क्या वाटर लेवल चेंज होने से गामा की वैल्यू पे कोई इफेक्ट हो रहा है? नो चेंज. क्या बी की वैल्यू पे कोई चेंज है? If the width of footing is going to change, if water level rises, no change. The effect will be on gamma value. So can I say QU, it will be directly proportional to gamma. It will be directly proportional to gamma, or you can say QU is some constant into gamma. So as the gamma value changes, your ultimate bearing capacity going to change, right? So in first case, the water level is much below the ground level. It means at this point, this is our case 1 or condition 1. In second time, the water level is at foundation level here. That is our case 2. So suppose when the water level rises to foundation level, the gamma I am going to use is, the unit weight of soil will be gamma submerged value. That will be our gamma submerged value. If the water level is at this level, case 1, gamma will be our gamma bulk. As we need to give answer, I can assume this gamma bulk. This bulking condition is a saturated condition, gamma saturated. We know that gamma saturated, it is nearly equal to half of gamma submerged. Generally, if we see the value of saturated unit weight, you will get like 20, 21 in this range, whereas gamma submerged value you will find in the range of 10, 11, right? So if the gamma value is going to be half, if water level rises to condition 2, the change in or the percentage reduction in bearing capacity will be, so for case 1, QU become C into gamma saturated. For case 2, QU become C into gamma submerged. So suppose this is 1, this is 2. If I have to find percentage reduction, it will be QU1 minus QU2 by QU1. If gamma submerged is half of gamma saturated, so the percentage reduction we are going to get is 50% or not. It means the value is changes. अगर वैल्यू हाफ हो गई है, इट मीन्स कितना रिडक्शन हो गया? अगर आपकी वैल्यू हाफ हो रही है तो रिडक्शन कितना हो गया वैल्यू में? 50% रिडक्शन. So our correct answer will be 50%. Right? Okay, let's move to next question. The contact pressure and settlement distribution for a footing are shown in figure. So the contact pressure is given and settlement distribution is given. Now you have to answer for which type of soil and which type of footing this distribution is correct. So this is your settlement. This is settlement distribution. This is pressure distribution. This is pressure distribution. You have to answer for which type of soil. For which type of soil this distribution is correct, or this distribution representing, if it is representing rigid footing on a granular soil, or you can say cohesionless soil, or flexible footing on granular soil, flexible footing on cohesive soil, or rigid footing on cohesive soil, or rigid footing on cohesive soil. Try to answer this one. Try to answer this one. This distribution is for, okay, let me discuss. B, flexible footing on granular soil. Okay, let's see. Just I will ask you some questions, just answer. Okay, if it is flexible footing, there are two parameters. One is settlement, one is pressure distribution, which is going to be uniform, which is going to vary. आपके सेटलमेंट और प्रेशर में से कौन सी वैल्यू यूनिफॉर्म रहेगी और किसमें आपको वेरिएशन देखने को मिलेगा? If it is a flexible footing, settlement will be, if it is flexible footing, settlement will vary. Settlement will going to vary. Okay, so here you will find variation. Whereas pressure distribution will be uniform. Yes, right. Oppositely, if I say it is a rigid footing, what about settlement and pressure? Now in this case, you will find there will be uniform settlement and there will be variation. There will be variation in pressure. Right. Now just take the case of sand. In case of sand, we know that the modulus of elasticity which we are going to get at center, it will be greater than modulus of elasticity at corners. E value is nothing but stress by strain. Strain is the representation of deformation, or you can say here it is settlement. If E is greater, it means deformation will be less. So you can say settlement at center, it will be less than settlement at corner. Right. So this is for sand. Now let's talk about clay. So the resistance due to cohesion value, it is more at corners as compared to at center. So you will get more cohesion resistance, or you can say cohesion at corner. We are going to get more than at center. If cohesion value is more, if resistance to deformation is more, it means settlement is going to be less. So settlement at corner, it will be less than settlement at center, right? Also, if settlement at center, it is less than settlement at corner. If settlement at center, it is less than settlement at corner. It means more pressure is applied at the center. More pressure is applied at center so that there will be less settlement. So can we say the pressure at center, it is going to be greater than pressure at corner? Right? Similarly, here I can see the pressure at corner, it is going to be greater than pressure at center. It is going to be greater than pressure at center. Now let's get back to our question. Now settlement is uniform, pressure distribution is varying. Settlement uniform, pressure distribution varying. So settlement uniform, pressure distribution varying. Settlement uniform, pressure distribution varying. It means it is a rigid foundation. It is a rigid footing. So rigid footing, this option eliminated. These two options eliminated. Now the pressure distribution, the pressure is more at center and less at corners. Pressure more at center, less at corner. So pressure at center, it is greater than pressure at corner. It means it will be sand. So it is a rigid footing on sand. So a rigid footing on granular soil. So rigid footing on granular soil. It is a rigid footing on granular soil. I hope now, Jay, your concept about the settlement and pressure variation is clear. You have given answer B. I hope now you got how it is going to be rigid footing on a granular soil. Is it clear now? Now this one is clear. Okay, next move. Okay. Now we have question from our SPT test, standard penetration test. We have question from standard penetration test. Standard penetration test. The number of flows observed in SPT for different penetration depth is given as follows. So for first 150 mm, the number of blows are 10. For next 150 mm to 300 mm penetration, the number of blows are 13. And from 300 to 450 mm, the number of blows are 15. The test is performed at 6 meters below the ground level, having unit weight of 19.5 kN per meter cube. The corrected N value is, what is the corrected N value? What is the definition of SPT value? SPT value, we know SPT is, it is the number of blows required for the penetration of last 300 mm penetration. It means first 150 mm penetration, the number of blows for first 150 mm penetration we neglect. So the Spt value is considered as the number of blows required for last 300 mm penetration. This is our Spt. This is going to be our Spt. So what will be the value of Spt? What will be the value of Spt? It is the number of blows corresponding to last 300 mm penetration. Just give me the value of Spt. Just give me the value of Spt. Okay, it is 13 plus 15. 13 plus 15. So we are going to get, this will be our observed, this is our observed Spt value. Yes, Riya, our observed Spt value. Suppose, let's say n. It will be equal to 13 plus 15. 13 plus 15, that is 28. Is it our corrected n value? Is this our corrected n value, or there will be correction required? What are the correction required on your Spt value? What are the correction required for your Spt value, Riya? Can you give me the answer in comment box? Which are the corrections required for your Spt value? Which are the corrections required on your Spt value, observed n value? That will be, your first correction is overburden correction. Our overburden correction. Now, why this overburden correction is needed? As you move to greater depth, what will happen? Suppose this is the borehole. Suppose this is the borehole, and in this you have inserted the sampler. You have inserted the sampler. Now you are going to apply the impact loading. You are going to apply the impact loading due to the fall of hammer. Now from which height? What is the height of fall of this hammer? What is the height of fall of this hammer? What is the height of fall of this hammer? And what is the weight of this hammer? We use in our standard penetration test. Can you give me the value? The height of fall and weight of this hammer. So weight of this hammer is 65 kg and height of fall is 75 centimeters. So due to this impact loading, you are going to push, or you are going to penetrate this split sampler into the soil. Now at a greater depth, there will be confinement. There will be confinement from these sides. Now this confinement pressure, that is our earth pressure. It is due to the overburden pressure. We know this active pressure, or you can say this horizontal pressure, it will be the function of our overburden pressure, sigma vertical, right? So due to this cause, we have to apply our overburden correction over this observed n value. So our n corrected, n1, it is n into 350 upon sigma naught bar plus 70. Sigma naught bar plus 70. Now what will be the your effective stress at 6 meter depth? What will be the value of sigma naught bar at 6 meter depth? It will be equal to gamma into Z. Gamma value is given as 19.5 into Z value is 6. It is equal to 117. 117. So now if I calculate here N corrected, it will be 28 into 350 by what is sigma naught bar? 117 plus 70. Can you give me the value of N corrected? What is the value of N corrected? Yes, Riya. Overburden pressure is 117. Can you give me the value of corrected N value? Can you give me the value of N corrected? Yes, it is 52.4. 52.4. Or exactly 52.41. So our answer will be 52.41. If suppose the water table is above the test level, suppose water table is somewhere here. If there is the effect of water, if there is water table above our test level, so we have to apply our dilatancy correction also. We also have to apply dilatancy correction. Dilatancy correction. In that case, N corrected would be N2 is equal to N1 plus half N1 plus 15 . Is it correct? Is it the correct formula? Or it will be minus? Or it will be minus? It will be N1 minus 15 or 15 minus N1? It will be N1 minus 15 or 15 minus N1. These are some confusion you are going to get in your exam also. So it will be N1 minus 15 or 15 minus N1. N1 minus 15 or 15 minus N1. What is the dilatancy correction? N1 minus 15. N1 minus 15. As it is not mentioned that where it is the water level. Where is the water level? That's why this dilatancy correction is not needed. But if in case it is given that water table or water level is above your test level or at your test level, then you have to also apply dilatancy correction. Always remember, before dilatancy correction, overburden correction is applied. So first you have to apply overburden correction, then only dilatancy correction. Right? So it is a sequence, first overburden correction, then only dilatancy correction. You cannot do like first apply dilatancy correction, then overburden correction. Clear? Okay. This is all about the session. I hope you enjoyed this one. So I have also given some question for your practice in this practice sheet only. To get the PDF, you can join the official Telegram channel of the Gate Academy. There you will get this PDF and some additional questions also. You will get 1 or 2 additional questions also. So, okay everyone, have a great day and thank you. This is all about the session. Do not forget to like this session and share this one with your friends and subscribe to the official The Gate Academy channel. Okay everyone, bye bye.